Okay, I think we can start. So hello and welcome everyone to our webinar today, how to deploy multi-cluster services with operators in Kubecarrier. My name is Caroline and I'm very glad to see that you're with us today, even after such a long time of online events only and social distancing, that you're not tired yet by all the overload of virtual events and that you're still motivated to learn something in this session today. Our speaker for today's webinar is Rastislav, who works as a Kubernetes software engineer at Kubermatic and who will be explaining how deployment of multi-cluster services looks like with the help of Kubernetes operators, the Kubecarrier Service Hub, and the Submariner cross-cluster connectivity provider. But before we get started with the exciting part, just two more notes to make. If you have any questions during the presentation, please use the Q&A chat window below so that we either can answer them straight away or in the Q&A session right after the talk. And in case you need to drop out earlier, no worries at all. We are recording the session. We will upload it to our YouTube channel. We will send out an email and you will find it on our website. So there is a bunch of ways of rewatching the webinar whenever it suits you. Yeah, and that's it from my side. So now handing over to Rastislav, the stage is yours.
Thank you, Caroline. So before we start, let me introduce myself. So my name is Rastislav Sabo. I work as a software engineer for Kubermatic. I'm specialized on multi-cluster application management, multi-cluster networking, and multi-cluster monitoring. We'll be speaking about those topics today. In the past, I contributed also to several other open source projects, such as Legato.io, FD.io, Conti VPP, or Cidr. So what's our agenda for today? We'll be talking about multi-cluster a lot. I'll start with some use cases for multi-cluster service deployments. Then I'll talk about how we can manage multi-cluster infrastructure easily with Kubermatic. Then I would go to multi-cluster application management. So once we have our infrastructure up and running, how we can deploy applications across multiple clusters. And finally, I will finish with multi-cluster networking, where I will talk about how we can communicate between different clusters so that our applications can be spanned across multiple clusters. I'll also show you a demo of multi-cluster application deployment with Kubecarrier together with multi-cluster networking with Submariner. So, as I said, let me start with some use cases. So why do we need to deploy applications across multiple clusters? One of the reasons may be close user proximity. We may need to serve users from different parts of the world without high latency. Another reason for that may be regional high availability. Maybe we want to minimize the impact of regional outages. Another reason may be some security and organizational separation. For instance, we may want to have dedicated clusters per organization or unit and still want to consume some services from the other organizational units. Another reason may be data locality. For instance, we may have some sensitive data that we can only store in on-premises clusters, but we still want to run some part of the infrastructure on the public cloud provider, and we want to consume those services backed by the on-prem clusters from the cloud. And the last but not least, the use case may be also edge computing, where we are talking about many small Kubernetes clusters spread across different regions. So let me start the multi-cluster journey with the infrastructure piece. So how you can easily manage multiple clusters across multiple regions. I guess that if you joined Kubermatic webinar, you know a bit about Kubermatic already. Kubermatic is a very good management platform for multi-cluster deployments that can span across different cloud providers. We support multiple of them. You can see some of them on the logos on the bottom right corner. And you can use Kubermatic to manage multiple clusters across all those cloud providers in different regions. And you can still use the single pane of glass for managing all those clusters. So single user interface, single dashboard, or you can still, if you would like to manage them through some API endpoints, you can manage all those clusters through a single API endpoint. Okay, so once we have our clusters running, let's talk about deploying applications across them. How can we easily deploy workloads across multiple Kubernetes clusters? Some answers for this are provided by the Kubernetes SIG multi-cluster, which is the source of two projects or concepts. One of the project is called KubeFet. KubeFet is able to do multi-cluster application deployments, but it also aims to solve much more than just application deployments. It also aims to solve the scheduling part and the policies, etc. It is quite widely used, but also quite complex to operate. A newer concept from Kubernetes SIG multi-cluster is called Work API. This time, it is a really simple approach for deploying workloads to multiple clusters. Does not cover any cluster registration or scheduling, only pure application deployment across multiple clusters. At this point, I think it's still just in the API definition phase. So at least I'm not aware of any particular implementation, but the concept is as follows. As you can see on the right side of the slide, you can define a work custom resource where you define the cluster where the Kubernetes resources should be deployed. And in the spec, you specify your workload. So in this case, it is just a config map, but you could define multiple different workload manifests in a work API CRD. The way it works is that you deploy this into so-called management cluster, which runs some control loop, and whenever this custom resource is created, it will apply the resources into the target cluster. Actually, also KubeFet is built on similar concept. So we always have some management cluster through which you manage the deployment of workloads into the actual service clusters. So those are like two upstream options. And the third option is something that we've built in Kubermatic, and it is called Cubecarrier. It builds on similar concepts, kind of as well. So we also have one management cluster through which you can control all the application deployments. So single source of truth, service hub cluster. And from that cluster, you can manage multiple service clusters that actually run the application workloads. What is different in comparison to the previous two options is that it works with Kubernetes operators only and by design. I'll say why it is based on operators later. But the main idea is that you deploy. As you can see on this picture, on the bottom side, I have our management cluster through which you can manage your application deployment into multiple clusters, and on the top I have a service cluster. And the way how Kubecarrier works is that you deploy an application operators into the service clusters. And then Kubecarrier discovers custom resources provided by those operators in the service clusters, and will make them available for consumption in the Kubecarrier service hub. And whenever some user wants to deploy, let's say, a replica, an instance of some application, they just do some trick that I'll explain later in the management cluster, and that Kubecarrier will automatically. Actually, the trick is that you just deploy a custom resource which is derived from the original one, and then Kubecarrier just takes that custom resource, deploys it into the service cluster, which drives the operator running in the cluster. And to conclude this slide, what's also unique on Kubecarrier is that it has built-in multi-tenancy. So it supports multiple service providers, which can run different service clusters and provide different applications. It also supports multiple service consumers or users. Okay, I've said previously that Kubecarrier was built to work only with Kubernetes operators, and now I would like to explain why. So in case that we need to manage application deployment into many clusters, let's say not 1 or 2 clusters, but 100 of clusters or even more, then managing this on the level of individual resources like config maps and services and deployments is just not scaling in many cluster scenarios. That's why we decided to use operators, who can actually manage a full application lifecycle in those service clusters. So not only the deployment of the application instances, but also upgrades. Let's say if it is some database, also backups and so on. To explain how it works on an actual example, let's say that we have one cluster where we run Kubecarrier, that is our management cluster. And then we have 3 service clusters where we have deployed an operator of some application. This is a Redis icon, so let's say it is a Redis Redis operator. Whenever these service providers of these service clusters registers those clusters in the Kubecarrier service hub, that service becomes available for service users. And the service user can interact with the management cluster through Kubernetes API to request an instance of Redis instance of running in any service cluster. So service user can just come here and deploy a custom resource, let's say provided by this operator, and it will say the service user will just say, please deploy this custom resource to the service cluster 1. Kubecarrier will just make that. It will deploy that custom resource in the service cluster 1. And the operator which is running in the service cluster 1 will then take an action and will deploy an actual application instance in the service cluster 1. And this way it works for many service users across many service clusters. I've also briefly said that Kubecarrier also supports multi-tenancy. So on this picture, you can kind of see like 3 roles or 3 personas that can interact with Kubecarrier. One of them is a platform operator. Of course, somebody needs to manage Kubecarrier itself. So the platform operator is that guy. It installs and manages the management cluster. It creates all the accounts for the service providers and service users. And then we have a service provider persona. That's somebody who runs service clusters, registers those service clusters in the Kubecarrier management, and also makes application, the custom resources of the applications of the operators running in the service cluster available for consumption in the service catalog. And as I said, we can have multiple service provider accounts. Those accounts are then isolated by the Kubernetes namespaces, and proper RBAC roles are applied in the management cluster. So multiple service providers can be onboard it into a single Kubecarrier management cluster, and that we have a separation between them. And the last persona here is the service consumer. That is somebody who wants to consume a service that some service provider is providing. Again, each service consumer operates within their own namespace with their own RBAC roles applied in the management cluster. So multiple service consumers are supported as well. Okay, so this was briefly about deploying multiple applications across multiple clusters. Let's say that we have our applications running in I don't know, 3, 4, 5 clusters. The next question is how we can interconnect those clusters on the networking level so that, let's say, backend running in cluster 1 could consume a database running in cluster 2. Again, an answer for this is provided by the SIG multi-cluster, which came with the concept of multi-cluster services APIs. This API actually extends the Kubernetes service concept across multiple clusters. So essentially, the Kubernetes services that normally work only within cluster could be made available across any set of clusters, any number of clusters that you join into a cluster set. And the way how it works is that in the cluster where I will call it provider cluster. Let's say it's a cluster which runs some application that needs to be consumed from a different cluster. So in the provider cluster, you would specify a custom resource with kind service export, where you refer to a particular service in a particular namespace. And then some multi-cluster services implementation would take action and make that service automatically available across all the clusters in the cluster set. And how it works is that it would create a service import custom resource in all consumer clusters. And from the consumer clusters, you can access your exported service using a domain name, which is similar to the domain name that you use for standard cluster-only services. So let's say this cluster was named my service in the namespace my NS. So you can consume this service then from the other clusters as my service.mynamespace.service.clusterset.local. An open source implementation of multi-cluster services API is, for example, Submariner IO. There are more coming, and there are also some cloud providers who are already supporting multi-cluster services API. Okay, and next, I would like to show you on an actual example how Kubecarrier works and how it works together with multi-cluster networking. So let me go to a demo. Just FYI, this demo was pre-recorded, so I will not be doing it in real time. I'll just play a recording, and I'll be explaining what is happening in the demo. The reason is that it's not that easy to set up multiple clusters with all this networking and Kubecarrier management. I mean, actually, to Kubermatic API, it's quite easy to deploy multiple clusters. It's quite easy to enroll them in Kubecarrier, but the networking part is a bit tricky. So let me play it, and I'll explain what is happening along it. So what you can see here is the Kubermatic Kubernetes platform, in which I have started 4 clusters. Each cluster runs at a different cloud provider in a different region. And one of the clusters we'll be using as our management cluster, and 3 clusters we will be using as service clusters. What you can see here is a console window split to 4 parts. So top left corner is the management cluster, and the rest 3 ones are service clusters 1, 2, and 3. The service clusters have been already registered in Kubecarrier in the management cluster. So if I issue kubectl get service clusters, you can see that service clusters 1, 2, and 3 are ready. Also, Submariner has been installed, so multi-cluster services will be working when we will need them. I will explain when we get to that. So first, whenever we want to interact with Kubecarrier, we need to have the accounts created. So any user needs to have an account created. I created 3 accounts, 1 for service provider and 2 for service consumers or tenants. So there will be service provider A and tenants A and B. In the user clusters, I have already deployed Redis operator. So you can see that in each one of them, we have a Redis operator already running. At this point, there are no Redis instances running in any of those clusters, only the operator. But the Redis custom resource has been already registered in Kubecarrier. So if we issue the command kubectl get catalog entry, we can see that Kubecarrier already discovered Redis in service cluster 1, Redis in service cluster 2, and Redis in service cluster 3. Those are actual custom resources provided by the Redis operator running in those service clusters. Next, we will use Kubecarrier to deploy an Redis instance in one of those clusters. And the way how we do it is that we deploy a custom resource into our management cluster. So this custom resource is derived from the original Redis custom resource. The only difference is that the API version refers to a particular service cluster of a particular service provider in Kubecarrier. All the rest of that custom resource is exactly same as it was in the original custom resource provided by the Redis operator. So stuff like password for our database, image that we'll use for the particle instances and all that kind of stuff that the Redis operator provides can be specified here. And the way how we deploy Redis instance is that we just run kubectl apply under a specific tenant account with this CRD definition. Before that, I'm running watch commands in each one of the service clusters. It is running kubectl get pods and grep for Redis. So we'll see whenever a new Redis pod is being started. So if I now deploy this custom resource to the management cluster, again, it refers to service cluster 1. So we should see Redis instance in service cluster 1 for the tenant A. And as you can see, it has been just deployed. So we have a tenant A namespace in the service cluster 1 with 1 Redis instance. Now we can use the exactly same deployment manifest with the same custom resource referring to service cluster 1 and service provider A just under tenant B account. And as you can see, we have a new Redis instance running in the tenant B namespace. And similarly, we could have a different manifest, which would be exactly same, but the API version would now refer to service cluster 2. And if we deploy this one, we should get a new Redis instance running in the service cluster 2, which is on the bottom right. And as you can see, we have a Redis instance running in the tenant A namespace in the service cluster 2. Okay, so now we have our Redis instances running in 2 different clusters. Now let's try to connect to that service from the last of our clusters, from the service cluster 3. So we have not deployed any Redis instance into this cluster, but instead we will try to connect to those Redis instances from this cluster. So before we can do that, we need to see what services are now provided by the Redis instances running in our service clusters. So let me run the command kubectl get services. And as you can see, we have Redis instance service running in tenant A namespace, and we have a Redis instance service running in tenant B namespace. Both are of type cluster IP. So normally they wouldn't be available from outside of this cluster. But we want to make them available. And what we can use for that is the multi-cluster services concept. So we can export these services specifically. So with this command, subctl export service, Redis instance namespace tenant A, I have exported the Redis instance service in the tenant A namespace across our cluster set. Subctl is a CLI tool provided by the Submariner project, but what it does essentially, what this command does is that it creates that service export custom resource in this particular cluster. And I will also export the service, the Redis instance running in the tenant B namespace, so that we can consume that across clusters as well. And if I do get service exports, we can see that those two service exports have been created, and they should be available for consuming from the rest of our clusters. So now we can go into the service cluster 2 and do the same. We can export the Redis instance running in the service cluster 2 in the tenant A namespace. And this way we will make it available for consuming across our cluster set. If we now go into the service cluster 3, from which we want to consume those services, we can issue the command kubectl get service imports. And as you can see, we already see all those services that we have just exported here. So 2 Redis instance services in cluster 1 and 1 service instance in cluster 2. We can try to connect to one of those Redis instances. For that, I will exec into a client pod. This pod is just a simple pod which has the Redis client installed. And the way how we can consume these services from the other clusters is, as I explained already, through the special domain name. So in this case, it is Redis instance.tenant A something.service.cluster.set.local. As you can see, I tried to resolve that domain name, and it resolved successfully to an IP address, which means that we should be able to use it from the Redis CLI. So I will execute the Redis CLI, and we'll connect to that Redis instance using this domain name. I'll use the password that we specified earlier when we requested a service instance via Kubecarrier. And as you can see, we are connected. If I issue a ping command, we'll get a PONG response from our Redis server. Similarly, we can also try to connect to some different instance. So let's say the other tenant A Redis instance running in the other cluster, it's working as well. So this was this was about the this is all about the demo. Just to summarize what we have seen here. So we had one management cluster through which we managed the deployment of our Redis instances into 3 service clusters. We started 2 Redis instances in the cluster 1, 1 Redis instance in cluster 2, and from cluster 3, we tried that the connectivity to those Redis instances is working after we exported those services through multi-cluster services. Okay, I think that was it from my side. This picture just summarized what you have seen in the demo. So again, we had 1 management cluster and 3 service clusters, right? And we were deploying those Redis instances through this management cluster. That's it from me. So now it's the right time for your questions, if you have any.
So first of all, thank you, and especially thank you for the demo, Rastislav. I saw that we're coming up 2 questions. So I'm starting with the first one. Okay, 3 questions now. How is intercluster communication secured? Any safeguards against insecure configs, misconfigs?
Yeah, so that's actually not part of the multi-cluster services API definition. I would say that's up to implementation. The particular implementation that I used for this demo is Submariner, and in Submariner case, it is IPsec between, for all the communication that happens between those clusters. Misconfiguration, again, it is highly dependent on a particular implementation of the multi-cluster services API. In the specification, there is nothing like network policies or something like that specified. So, short answer: implementation specific.
Okay, thank you. Then heading over to the second question, how are VIPs allocated to multi-cluster servers? Would they be the same across clusters in the set? How is the CIDR range configured?
Right. Again, the short answer would be implementation specific. Again, the multi-cluster services API is not saying anything about those details, but in Submariner case, it's all configurable. So you can configure those CIDRs. Frankly, I'm not sure whether the IP address would be the same in each cluster, but again, it's implementation detail. Because normally you always interact with those services only through their domain names, and those are the same in each cluster.
Okay, I hope that answers the question. If not, please let us know in the chat. And the last question, how exports are picked up by other clusters? Some sort of control?
Yeah. So that's, again, that Submariner implementation. That's something that I have not shown in the demo. I set up the cluster federation before the demo, but similar to the concept that we have in Kubecarrier, that we have one management and then multiple service cluster. In Submariner case, you would first install Submariner into some cluster, and then you would join the rest of your clusters to that one, the management cluster. And it is all then all managed by the implementation, which is in this case Submariner. So whenever I create a service export custom resource in some cluster, Submariner is watching for those custom resources, and Submariner would automatically do whatever magic needs to be done. So first, it would create the service imports in the rest of the clusters, and then it will do all the network plumbing that needs to happen so that the communication is possible.
And one more. Thanks for the great demo. What's the shell format used on your demo sessions?
Yeah, that's ZSH. So yeah, and welcome.
Are there any further questions that you haven't put in the Q&A chat window yet? No, it seems like not.
In case you have more questions, feel free to reach out to me via email. You see the email address on the screen right now. I'm happy to answer any questions later.
I see there was coming in one more. Does it provide multi-cluster resilience? Like if no endpoints in one cluster, it will hit another? Yeah,
exactly. So in case we have backends of some service running in more clusters, normally it would load balance between them. In case that one of if some endpoints in some cluster or whole cluster is down, it would load balance only to those which are alive.
Great, thank you. Yeah, so thank you very much for joining, Rastislav. Thank you very much for doing the webinar today. I hope this was an informative session for all of you. And as we've already said, if there still should come up some more questions later on, or maybe questions that you don't want to ask right here, right now, you either can send us an email to marketing@kubermatic.com, or you can reach out to Rastislav to go through your open topics directly with him. And yeah, just very short on our own behalf now, we have some good news for Container Days. So on-site events are possible again. The vaccine numbers all around the world are going up, which yeah, makes us be more optimistic, and which makes us, yeah, so that we can finally prepare for an exciting on-site experience. So save the date for September 21st until 23rd. And join us for deeply technical talks and hands-on workshops, and just enjoy the incredible atmosphere at our location in the city of Hamburg. Yeah, so make sure you grab your ticket right away. And very quickly, before we end the session today, we are always happy about new followers on Twitter and about new GitHub stars for our open source projects. So support is highly appreciated. Yeah, and that's it for today. Thank you very much for joining. I hope you enjoyed it, and hopefully see you soon again. Thank you.
Thank you. Goodbye.